I'm looking at this polynomial. It's a trinomial. It's in descending order. You know the scheme now. It's a trinomial, the middle strategy. It's in descending order. No greatest common factor, no negative leading coefficient. Special product, no. This is not a perfect square. This is even negative. So there's no special product here. Then I'm looking at the next step. I did have that. Okay, here it is. Okay. So descending order, greatest common factor, negative leading coefficient, no. Because the last term is not positive and this is not perfect square, done with this. Then the next strategy says 1 is a leading coefficient. No, unfortunately, it's not the case. 1 is not the leading coefficient. So I'm at the last chance. This is my last chance to factor the polynomial. However, since we looked at the quadratic formula, you can say, forget it. I mean, why can't I use the quadratic formula? Yes, you can, if you want to. So you want me to show you how to proceed with this using factoring, or you say, well, at this point, nobody's forcing me to factor, and that's true. No one is forcing you to factor. I want to use the quadratic formula. That's fine too. What do you want? You want to factor? Okay. Okay, so let's look at factoring. So here's the procedure I present to my students in previous classes for factoring this. So this is, one more time, the last chance. It's the most complicated type in which the leading coefficient is not 1, and this is not a perfect square. Okay, ready? So I try to find two numbers whose product is this number, -30, the product of these two, and whose sum, the same numbers, whose sum is this, +7. And I'll show you what happens next. So I'm looking for two numbers whose product is this, -30, and whose sum is this. Since the product is negative, one number must be, and one number must be, there is no other way. So then I can already say positive and negative. So now let's think. Can I find two numbers whose product is -30, one positive and one negative, and at the same time their sum is +7, and they are? Very good. So 10 is positive and -3 is negative, and 3 is negative, because the product is indeed -30 and the sum is indeed +7. Both conditions have to be fulfilled at the same time. Now I change the equation, rewriting 2p squared plus 10p minus 3p minus 15 equals 0. This is still the same 7p from before. I didn't really change the equation, but with the numbers that you gave me, which are correct, these are the only numbers that work here, the only pair of numbers. The sum is this, and the product is that. I replace the 7p by 10p minus 3p. Now, if you try to go back and combine my terms, you're going backwards instead of moving forward. So what do you think I'm going to do now with 4 terms? The only thing that I can do with 4 terms, grouping. The reason why I cover it, and I do this when I perform a calculation myself, I don't look. I'm not going to cover it with my whiteout, but I will not look before I write, because I may be tempted to write x minus 2 instead of x plus 2. It's very tempting. So I look at the first two. What do I factor out? What is left in parentheses? What do I have to have from the other two? If I don't have it, I can't continue. I have to write it first before I look. That's it. That's exactly what I was saying. Because if I try to guess and if I look and who knows what I write, I cannot fabricate it though. It has to be there.
3.
Not only. Very good. So now I have the common factor that comes out. And what is that common factor? Correct. But I just wanted, the order is perfect, but I just wanted to write it as, what is the common factor that comes out?
+5.
Indeed, p plus 5 is the common factor. What is left?
2p minus 3.
That's it. Finally, after all this effort, we have two solutions for p. And the first solution for p is awesome. And the second solution for p is very good. But who cares about p? No one. The solution still has to be in
X.
exactly. I have to go back. I replace p by what?
X.
So x to 1/3 equals this. And the second equation is
X to
1/3 equals halves. Very good. So two equations. X to 1/3 equals -5 and x to 1/3 equals 3/2. What do I do to the first one and what do I do to the second one? Now I have to dig deep again, because now I have to say to myself, oh, what type of equation is this? And how do I solve it? And the answer is what does power 1/3 mean? If I say,
-3 X. No.
nope, what if I say the square root of x? Can I write this as a power?
1.
Over. A radical is always an exponential expression with a fractional exponent. Right, so then I know what x to 1/3 is then.
X to the 3rd.
The cube root. The cube root of x equals -5. So then what type of equation is this? We discussed it last time. What type? Radical equation. Perfect. What do I have to do to both sides to get the solution here? Very good. Thank you, Danielle. I have to cube because that's the only recipe for undoing the cube root. So then the solution is x equals -125. Notice the fact that I always have to check. If you remember, we said last time, I have to check. So when we go back, we can check. This is indeed true. The cube root of -127, -125 is -5. Okay, what do I do here? It's the same thing. It's the cube root of x equals 3/2. In order to undo the cube root, it's the same procedure. I have to raise both sides to power 3. The left-hand side is perfect, and the right-hand side is, remember how we raise a fraction to a power. We take the numerator to that power, and then the denominator to that power. What do we get? 27 over? Very good. Both work. You can go back and replace it in here. The cube root of 27 over 8 is indeed 3/2. Any questions for me? Any questions for me? Any questions? I would like to review some inequalities with you in 1.7. Section 1.7, inequalities. And interval notation as well. So let's start by looking at 46 on page 203. So for x minus 3 divided by 6 plus 2 greater than or equal to 2x minus 1 divided by 12. Okay, what type of inequality is this? What type of inequality? We have to identify it because as you know now, by now, everything has a different recipe. If it's linear, I do one thing. If it's quadratic, I do something else. If it's polynomial, if it's rational, if it's so on and so forth. Everything has a different strategy. So what type of course, this is a linear inequality. It does not have x in the denominator. It doesn't have radicals. It's just a clean linear inequality. Perfect. As before, when I see fractions, I want to do what to them? Perfect. So let's do the same thing here. How will I eliminate all three fractions? There are three fractions. This over 6, this over 1, this over 12. So three fractions, I want to eliminate all three denominators. What will I multiply both sides, each and every fraction by to get rid of fractions? I will multiply by, yes, because they are fractions, I'm going to multiply by 12 over 1. It will be easier to simplify. So 12 over 1, this one doesn't need 12 over 1. 12 is good enough. And this one, 12 over 1. So when I simplify 6 and 12, 2 at the top, do you agree? So then 2 quantity 4x minus 3 plus. The next one is easy because the denominator is 1, so then I get, perfect, greater than. The last one is also easy because the denominator is 12. I'm multiplying by 12, so there is no factor in front, and I get what? Perfect, awesome. What will be my next step towards solving this linear inequality? Yes, I have no choice. And I will have 8x minus 6 plus 24 greater equal to 2x minus 1. So I have distributed. My next step must be, please do not move terms around till you completely clear and clean up the one side, the left-hand side, and the other right-hand side. And then we decide what to do. 8x plus 18 greater equal to 2x minus 1. Perfect. Now, like with linear equations, I want to separate the variable from the rest. So yes, I want to move 18 to this side, and I want to move 2x to the other. So what would you say I should write?
6x.
Perfect. Greater than or equal to?
19.
Very good, but negative. So when we move a term from one side to the other, we have to change its sign. Very good. And final step, x greater than or equal to? Perfect. In interval notation, on the real line, 0 is in the middle, negative infinity, infinity. Real line or number line. Negative 19 over 6 is a little bit to the left of negative 3. So I'm going to say right here, negative 19 over 6. I don't really care for units. I just want to show what I'm going to write, where it's coming from as the interval notation. So which side is x being greater than or equal to negative 19 over 6? Which side will I find it? Of course, to the right-hand side of negative 19.6. Because it's an equal symbol, I will use a bracket, and it goes all the way. So I will say x is a number in the interval. Exactly what I see. The bracket to the right of negative 19.6, comma, infinity with a parenthesis. This is the interval notation. would like to, I know we have only 1 more minute left, and then I'll let you go. Just one more.
I just have one
Yes.
question.
Yes, please.
In that case, when the x would be negative, when we divided by x.
Yes, we will have to
One would
switch.
switch
Yes. So if I had, for example, -6 here, I would have said less than or equal to. Yes, of course. So I'm going to stop after just this problem. Let's say 56. So 3 less than or equal to 4x minus 3 less than 19. And if I ask you what type of inequality is this, you can say linear, but it's more than a linear inequality. It's a compound inequality, meaning two inequalities put together. And here's why. And if you'd like to look for a moment, this is one inequality, and this is the other. But we can solve both at the same time. What will be the first step? What do you want to get rid of in order to get closer and closer to x alone, or isolate x inside? What would I have to do to all three sides? Yes, I have to remove the weakest link. So 6 less than or equal to 4x less than 22. And final step, I have to remove. That's it, and we're done. So this is 6 divided by 4, which is 3/2, less than or equal to x, less than 22 divided by 4, which is 11/2. How will you write this in interval notation? X is in the interval. Yes, 3/2, comma.
Going to
And that was a parenthesis because it's not equal.